Hello, I'm Akila from CSCA. My topic is Deep Belief Networks for Feature Extraction from the course Artificial Neural Network. Coming to the introduction, the automatic feature extraction essentially in deep learning. Traditional models need manual features and the DBNs learn high-level features through layered training. It combines unsupervised learning and fine-tuning. This is the introduction about the feature extraction in the artificial neural networks. Coming to the topic, what are artificial neural network? Composed of artificial neurons are the nodes. It contains the layers like input, hidden, and output, the forward propagation of inputs, and the back propagation adjusts weights to reduce error, used for classification and regression, etc. Coming to the limitations of traditional artificial neural network, shallow structure, it limits learning capacity and it requires large labeled datasets. Handcrafted features often inadvocate the struggle with unstructured data like the images and the text. Introduction to deep learning, part of machine learning using multi-layer neural networks, learns from raw data without feature engineering, effective for speech, vision, NLP task, and supports end-to-end learning pipeline. This is the introduction of deep learning, which is a part of machine learning. It uses multi-layer neural networks, learn from raw data without feature engineering, effective for speech, vision, and NLP tasks, supports end-to-end learning pipelines. What is a deep belief networks (DBN)? Composed of stacked restricted Boltzmann machines, which is RBMs, learns hierarchical representations layer by layer. Each layer captures more abstract features. Top layer connected to supervised classifier. This is about the deep belief network. The structure of a DBN, which involves it contains the layers of input, hidden, and the output input RBM M1 and RBM2 and the output. In this, the hidden layers are the RBM1 and the RBM2. The RBM are trained sequentially. Hidden layer of one becomes visible layer of next. Output layer uses softmax and logistic for prediction. What is a restricted Boltzmann mission (RBM)? Undirected graphical model is called the restricted Boltzmann mission. Visible input and hidden latent units, no intralayer connection, learns to model probability distribution of input data. The training a DBN. Pre-train each RBM using constitutive divergence. Greedy layer-wise training improves convergence. Stack RBMs to form DBN. Fine-tune whole network using supervised learning. This is about the training a DBN. DBN versus other deep models. Good for unsupervised, where the DBN is good for unsupervised feature learning, where the CNN best for images and spatial data. Autoencoders useful for data compression. The GANs are powerful for generative tasks, where each other deep model have a specified one effective one which is best for images and data compression and generative task, where the DBN is good for unsupervised feature extraction and the learning. The feature extraction using DBN learns features directly from data, good at identifying patterns in high dimensional data, reduces dimensionality, input for other machine learning algorithms like SVM, support vector missions, and k-nearest neighbors are the machine learning algorithms which are used for the feature extraction. using DBN. The applications of DBN: image and speech recognition, handwritten digit classification, which involves in the MNIST, and anomaly detection, feature extraction for clustering, the clustering which involves in the process of combining similar data into groups. It is used for the data manipulation and data warehousing. These are the applications of DBNS. The advantages of DBNS: effective with unlabeled data, avoids vanishing gradient via layer-wise training, produces meaningful abstract features, can initialize weights for deep neural networks. The advantages of DBNS: it very effective for unsupervised or unlabeled data, which does not contain the deep understanding of the content, involves in the unsupervised learning, avoids vanishing gradient via layer-wise training, produces meaningful abstract features, can initialize weights for deep neural networks. The k-nearest neighbors and decision trees random forest are the most used machine learning algorithms in the DBNS and the artificial neural networks. The limitations of DBNS: high computational cost, difficult to implement at scalable, sensitive to learning rate and batch size, largely replaced by CNN and transformers. The tools and libraries for DBNS: TensorFlow, manual implementation, and PyTorch, which involves in the flexible dynamic graph building. Deep learning: it involves in the Java-based deep learning, MATLAB. It involves in the neural network toolbox. No official high-level DBN API in the modern frame. The TensorFlow, which is used in the manual implementation, and the PyTorch, the flexible dynamic graph building. These are the tools and libraries which are used for the feature extraction in the DBNS. The DBN in feature extraction pipeline: collect raw input data. The next step involves in the train RBM layer wise, and the third step involves in the extract features from top hidden layer, use features for downstream machine learning tasks. These are the DBN in feature extraction pipeline steps. The visualization of learned features: visualize RBM weights as filters. Early layers learn edges and textures. Later layers learn object parts or semantics, useful for interpreting model behavior. These are the visualization tools and techniques of learned features in the DBNS of artificial neural networks. The visualize RBM weights as filters. Early layers learn edges and textures. Later layers learn object parts or semantics, useful for interpreting model behavior. Coming to the case study involves in the DBNS. The MNIST digit recognition. The DBN trained on grayscale 28 by 28 images. Pre-training improves accuracy and speed. DBN can classify digits with greater than 95% accuracy, paved the way for deep learning success. This is the case study involving DBN artificial neural network, which involves in the digit recognition in the trained of grayscale 28 by 28 images, which involves the greater than 95% of accuracy and speed with efficiency, paved with the way for deep learning success. The recent alternatives to DBNS: the CNN, which is efficient with spatial hierarchies; the transformers, attention based and great for sequences; autoencoders, compression and reconstruction. These are the autoencoders used in the DBNS, which is The compression, which compress the images or the files into a low GB files, and the reconstruction, which involves the building of a new file with following the same steps. The DBNS how mainly used in academic research. Coming to the conclusion of the topic, the DBNS were fundamental in deep learning, still useful for unsupervised pre-training, valuable in settings with limited labeled data. Knowing of DBNS aids understanding of deep models. The DBN played a very fundamental role in the artificial neural networks in the field of feature extraction. It is very useful for unsupervised pre-training. It is valuable in setting with limited labeled data. Knowledge of DBNS aids understanding of deep models. This is the conclusion about the topic. Thank you.